to this tutorial of low-level system design. And in this particular video, we are going to see the open-closed design principle. So what is this open-closed design principle? So this open-closed design principle, so we have the 5 solid principles: SOLID. So S stands for single responsibility principle that we have seen. Now we are going to see the open closed principle in this particular video. So O stands for open closed principle. So what this open closed principle states, that it states that a class, a module or a function must be open for extension but closed for modification. So let me write over here. A class, module or a function must be open for extension but closed for modification. So what this means is, basically, suppose you have two classes, class A and class B, and class B is the subclass of class A. Okay, so if you have only one class, so what should be the approach of the developer? Like, if he has to write any new function, then he will have to update the class. But open close principle states that you don't have to update the class, but you have to extend that class. So it is not open for modification, so it is closed for modification, but it is open for extension. Okay, so we have to extend a class. We do not have to modify the class if we want to update or change our functionalities. So this is the open closed principle. Okay, now we can how we are going to deal with this open closed principle. So there are basically two approaches via which we can apply this open closed principle. So what are the approaches to implement? So what are the approaches? So I am talking about approaches. What are the approaches? So it clearly states that we have to extend a class. So we have to create a subclass. So in Java we have interfaces, abstract classes and inheritance. So basically there are only two methods by which we can ensure this open closed principle. So first one is inheritance, that is the normal inheritance, and the second approach is by using interfaces, or abstract classes in Java. So what are the approaches that I have mentioned? They both have some advantages and disadvantages. Talking about the advantage of using interfaces or abstract classes in Java. So if we are using normal inheritance, then what is the demerit of normal inheritance? The demerit of using normal inheritance is that it provides tight coupling. But if you are using interfaces or abstract classes in Java, so what we are basically doing, So if we are implementing interfaces, so by default what interfaces do, they implement their abstract methods. So, and abstract classes also, like it is an abstract class, so it must be having one abstract method that is overridden in its subclasses. So they both are using overriding, so they are using overriding, they both are using overriding. And also they do not provide tight coupling, so they provide loose coupling. Okay, so they provide loose coupling, they provide loose coupling. Now what is the difference between tight coupling and loose coupling? So basically tight coupling is something, let's talk about tight coupling. Let's talk about tight coupling. So tight coupling is something like if there are two classes, suppose class A and class B, and class B is a subclass of class A. So tight coupling is basically the strong interdependence between two classes, strong interdependence between two classes, that both of the classes are interdependent, the objects of the classes are dependent on each other. So if we are modifying the base class, then we have to do certain modifications in the derived class. I repeat, if I do any certain modifications in the base class, then I would have to do certain modifications in the derived class also. So this is purely a headache. So tight coupling is a headache because we have to make certain modifications in one class because we have changed the functionalities of another class. So it shows strong interdependence between classes, strong interdependence between classes. Okay, and loose coupling, so interfaces provide loose coupling. So this is advantage of using interfaces. Okay, now what is the disadvantage? If we talk about the disadvantage, if we are using normal inheritance, then we can use public like various access specifiers, public, private, protected. But if we are using interfaces, then by default they are abstract. So if we are declaring any method in any method in interface, suppose like I create one interface, this is an interface. Okay, this is an interface. Let's just name it as interface. We can name it as comparable. Suppose comparable is an interface. So if we declare here suppose void some function, suppose void compare function, okay, if we declare over here. So comparable is a interface and we are declaring void compare method in it. So by default it is a abstract method. Okay, also after Java 1.8 default and after Java 1.8 default and wait a minute, after Java 1.8 default, static and abstract was already there, so by default it is abstract, and default and static were also added. Okay, but by default it is abstract. Okay, and so in normal inheritance we can use various public, private and protected keywords for your data types as well as member functions. But when we are talking about interface, they are by default static final public. They are by default static final public. Okay, so what I was saying, that the data types, if you are declaring any data types in this interface comparable, then by default it is public static final. Okay, so we cannot make it protected or private. So it is one disadvantage of interface, but the advantage is loose coupling. So this was one very much practical. So this interfaces is very much practically used in industries because of the loose coupling. So these are the only two approaches via which we can solve the problem of open close principle, and this solid principle it was given by Uncle Bob. Okay, he goes by some Martin name, John J Martin or something. You can Google it. Now so this was about tight coupling. So I explained you what is tight coupling, what is open close principle, what are the approaches. Now let's talk about the first approach. So we are talking about normal inheritance. So the first approach is via normal inheritance. So okay, one advantage of interface, let me talk about one more advantage of interface. So it provides tight coupling. Normal inheritance provides tight coupling. So if I am saying that normal inheritance provides tight coupling, this is one disadvantage. Another disadvantage of inheritance in Java particularly, the disadvantage of inheritance is basically that multiple inheritances is not allowed in Java. So no multiple inheritance, though it is allowed in C++, but in Java normal your multiple inheritance is not allowed. Multiple inheritance is not allowed. But if we are talking about interfaces or abstract classes in Java, the interfaces can be used. For multiple inheritance. Okay, so interfaces can be used for multiple inheritance. Okay, it can be used for multiple inheritance. We write it over here. Okay, so interfaces can be used for multiple inheritance. Okay, so let me just give you a brief idea. So if there of multiple inheritance, so suppose this is class A. Suppose this is class A, this is class B, and this is class C. Suppose this is class B and this is class C. Okay, and if one class tries to extend in this manner, suppose class A extends in this manner, so class A extends from class B, so here extends. So class B and class C are the base classes and class A is the derived classes. So this is what is multiple inheritance. So this is not allowed. But suppose this is class A, suppose interface B, suppose this is interface C, and class A implements interface B and class C implements interface C. So this is allowed. So multiple inheritance through interfaces is allowed in Java, whereas normal multiple inheritance is not allowed. So this was some theoretical aspect. You must have known this thing. So what I am going to do, I am just going to show you now how, with the help of normal inheritance, though it provides tight coupling, can be used for ensuring open closed principle. Okay, now let me take you to an example. So I am going to take example of a bakery shop. Okay, and this example I have taken from Geeks for Geek, and I am going to show you with this example. This example that how open close design principle is working in Java using normal inheritance. Okay, now suppose that there is one person named Jane. She starts a bakery shop and decided to keep it simple and scale as in accordance with her sales. So according to her sales, she wants to scale her bakery shop, and she decides to keep it simple. So I am going to show you the code, but before that we are going to see the UML diagram. So what is UML diagram? This is nothing but Unified Modeling Language diagram, and you will be able to see the blueprint. So UML diagrams are basically for the stakeholders who are not into that much of coding and stuffs, can communicate with other engineers through this UML diagram. So UML diagram can give you the overview of all the classes. So I am basically going to talk about class diagrams. Okay, class diagrams. First we are going to see the class diagrams, and then we are going to see the code of these class diagrams, and we will understand how open close principle is implemented using normal inheritance. Okay, so let's see this example. We have a class diagram. This is basically a UML diagram, Unified Modeling Language diagram, which shows how normal inheritance is working, and how normal inheritance is helping in maintaining the open close design principle. Okay, so this is the cake class, which is the base class or the parent class, and pineapple cake and chocolate cake are the derived classes which are inherited from this cake class. They are the child classes, and they have these data members and these member functions. Okay, so this was it. Okay, now we can clearly see that they have constructors, public constructors. Chocolate cake class has chocolate cake public constructor. This is also having a constructor, and with the help of this constructor, we can actually assign the values of size and weight. We can actually assign the weight of size and weight over here with the help of these constructors, and with the help of super keyword. We will see in the code itself. With the help of super keyword, we can send these values to this cake class. Which is the main class. Okay, so we are going to see how the code is actually working, and also let me just recap you what all I have said. After that we will we will see the code and understand this principle in depth. Okay, so uh, what I told, what is open closed principle, what are the approaches that we can follow, normal inheritance, and by using interfaces. Now we saw what was tight coupling and what was loose coupling. Okay, and what are interfaces and what normal inheritance is, and what type of inheritance Java does not allow. So multiple inheritance is not allowed, multiple inheritance not allowed. And with the help of one example of a bakery shop example, we are seeing the UML diagram, and now we are going to see the code of how this how we can apply the open closed design principle over to this UML class diagram. Okay, so hey guys, welcome back. And again I am going to show you how we are going to create this particular class diagram, how we are going to code it out and work on it. Okay, so you must have gone through the UML diagram and what open close principle is all about. Now let's code it out. So first of all, I'm going to create this cake class, and then I'm going to create the pineapple cake class and chocolate cake class, and through the main class we are going to implement the methods. Okay, now let's start to code it out. So first of all, I'm going to import java.io.all. So all is the thing that I'm going to do, and again I'm going to create cake class. So class cake class, and C should be capital because class names are by default capital. It's a very good practice to uh, keep the class names, the first letter of the class name as capital. And I'm going to have, so I can clearly see it's int size and it's private. So private int size. Okay. Now what this is showing, this is showing that this is not used yet, this is not used yet, so it's not an error. Now again I'm going to create private, this is a float, and weight. So these two things are done, the size and weight I have declared. In this similar manner, what I'm going to do, I'm going to create a cake. What is cake? Is a constructor. So cake constructors have no return type, and it's public, is a public constructor. And what this constructor is taking, so it will take size and weight, float, weight, and I'm going to use this keyword, this size equal to size, this weight equal to weight. This much is done, this much is done. Now what I'm going to do, I am going to create this bake method. Okay, I'm going to create this bake method. So public, this is a public bake, this is a public bake method, and its return type is void, and it's taking parameters, no parameters, it will not take any parameters, and it will just print uh, the cake. So system dot out dot println, I will just give a message, the size and the weight. So let me just write over here, baking cake with base as vanilla. So the base is by vanilla, and what I'm going to do, I'm going to system dot or dot println. Also I'm going to print the size. Size is I'm going to print the size, this dot size, this dot size, and also the inches and weight. Size is in inches and weight is basically this kg. Yeah, this much is done. I hope the code is visible. So this is all I did till now. I have created one cake class and declare two private data members and public data members, one constructor and one public data member function bake, and it's just printing out the size and weight now. So this part is done. So the base class is created. Now it's time to create the pineapple cake class. So we have to create the pineapple cake class. Now we can clearly see this pineapple cake class is extending from the base class cake. So I will just write here class pineapple pineapple cake. It is extends from your cake class. Okay. Now it is also having size and weight. So I am just writing here int size, and it is private int size, and also I have private float weight. Okay. And again what I'm having here is the public pineapple cake constructor. So I will write public pineapple cake. This is the constructor, and this constructor will take value size and weight. So int size, int weight, this dot size equal to size, this dot weight equal to weight, this dot size equal to size, this dot weight is equal to weight, and it's giving short of okay, it's float actually. Now I have created the pineapple cake uh, constructor. What it's saying, implicit super constructor cake is undefined, must explicitly invoke another constructor. What is this error? What is this error? Yeah. Okay. So I have created private size and float, and I am just taking the size and weight in this constructor. So the problem again is like it's the problem. You can see the problem here is implicit super constructor cake is undefined. So cake is undefined actually here. It's just telling that it must be explicitly invoked another constructor. So what I'm going to do, I'm going to use what I'm going to do, I'm going to use a super keyword. So what super keyword will do, you can clearly see super keyword, and I will just pass over size and weight. So this parameter I am going to pass, to the cake class. Okay. Now why I did this? Because it is extending from this class. So it is having, like, we have to give some parameters to the cake class, because we have a subclass. Okay, because the cake class is extending from like the pineapple cake class is extending from cake class, so we have to give the cake class. So what does extending means? That it can access the parameters of like it can access all the uh, public members of the parent class. So here I am trying to access the public members of parent class through the super keyword. So super keyword will call out for this constructor. Okay, so it will call out for this constructor. Okay, and if I am not writing the super keyword, then it will just give me this error that implicit super constructor cake is undefined. So I have to define a super constructor, because implicitly it is undefined for cake constructor, so it must be explicitly invoked. Okay, it must be explicitly invoked. So I am just doing the I am explicitly invoking it. So super keyword is referring to the parent class instance. Okay, and here you can see it's giving a very small error. I will just fix it, and over here also. Okay, now this is done. After this is done I am going to create a decorate cake function. So decorate cake, so so this is a private uh, method. So private uh, void decorate cake, this is a decorate cake method. And what I am doing, I am going to just print decorating cake and adding pineapple pieces. Okay, this is done. Decorate cake method, I have created a decorate cake method uh, by the name decorate cake, and it's just printing two little things. And again I am going to create add cream method. This is private add cream. You can see I am following camel cases, it's a good practice. So add cream, what it will do, it will add, suppose adding white cream, adding white cream. Okay, this is done. So private, it is a return type is void. Okay, this much is done. And you have a bake which is a public. So public void bake method. Now what this bake method will do, it is going to call super bake, super dot bake. What is super dot bake? You can clearly see we have a bake method over here, so it will call for super dot bake. Okay, it will call for super dot bake, and again it will call for decorate cake and add cream. So let's call add cream, let's call decorate cake also. I'm calling these methods, and I'm just doing system dot out dot println. pineapple cake plus this dot size, so it will access this one, this data member, plus inches is ready, plus uh, this dot plus this dot weight so this dot weight kg. Okay, so this is done. After this is done, so what we have done actually is we have created a pineapple cake class which is extending from the cake class, and we have used super keywords to call out for these two things. Okay, if we are not using super keywords for this constructor, okay, for this constructor call, then it will give error, okay. And again what I'm going to do, I am just going to create one more. So this class is done. Now we have to create this chocolate cake class, and you can see that these two are very much similar. Okay, these two are very much similar. So what I can do, I can just copy it and just paste it over here, and you can see it's giving the message that it is already defined. Of course it's already defined. Now I will just change its name to chocolate cake. Let's change it to chocolate cake. Okay, I'm just changing it to chocolate cake. Everything remains the same, but now I am going to add here chocolate chips, suppose, and adding chocolate cream, suppose, chocolate cream, and again this is a chocolate cake, and its size and its weight. Okay, so this much is done. Okay, now let's create the main method. Okay, let's create the main method. So this much is done. You can clearly see we have created the cake class. We have created pineapple cake and chocolate cake, which extend from this cake class, which shows hierarchical inheritance. We have used the super keyword because we have used here a constructor. So super keyword is useful for calling the public member functions of the parent class. Okay, and we have done that only. Now let's create the main method to demonstrate how the code is functioning. So what I will do, I will just write here class baker shop. It's the file name baker shop, and let's write here public static void main string, and okay. Now what I'm going to do, I am going to create pineapple cake and chocolate cake. Okay, and what I will do, I will just call for the bake method. Okay, I will just call for the bake method. So let's create it. So let's create the pineapple cake first. So I have pineapple cake 1, or pineapple cake is equal to new pineapple cake, and I am just passing two parameters, size and weight. Suppose size is suppose 4 and weight is suppose 10. And now I will use this pineapple cake dot bake method, because bake method is there in pineapple cake, you can see. And again I will do this for a chocolate cake as well. Chocolate cake is equal to new cho chocolate cake, and pass here 10 and weight as 20. Okay, and I will just use this chocolate cake dot bake. Okay, now you can clearly see we have created it, and this is of no use. Now let's try to run it. Okay, so this is working perfectly fine. So this shows the open close principle, open close principle, uh, and this is a bakery shop, uh, bakery shop, you can say sales. Okay, now so we have seen how we are using inheritance to demonstrate the open close principle. So you can clearly see this cake. So we have this cake class, and if we want to have pineapple cake, we have extended the cake class. If we want to have chocolate cake, we have again extended this cake class. If we want to have another uh, cake, suppose a vanilla cake or something like that, then we will again extend this class. So we are, what we are doing, we have opened the class for extension, but we have closed it for modification. We are not modifying anything in this cake class. So this is the demonstration of open close principle. We have seen the UML diagram, working of UML diagram. We have seen the open close principle, and let's just see the dry run of this code. So we have created one pineapple cake class, pineapple cake object of class this, and we have accessed the bake method. Okay, so what this is giving me, so let's just print over here system dot out dot println, just print here new line. Let's run this code again. So let's see what it's printing. So what it's doing, so I have created an object of pineapple cake, and I have given 4 and 10 into it. So here is the pineapple cake. I have given 4 and 10 into it. So it is initializing super of 4 and 10. Super 4 10. So it is giving it 4 and 10. Again, what I am going to do, I am initializing them as 4 and 10 as well. Okay. So let me write here. This is 4. This is 10. Again, this is also 4. This is also 4, and this is also 10. Up to here we have done it. Okay, now what this is what we have done over here. Now when we are calling the bake method, pineapple cake dot bake, so pineapple cake dot bake, so we have bake over here. Now what it's doing, it's calling super dot bake. So super dot bake is giving baking cake with base as vanilla, size is this, and again adding a size is this and this, and again it is calling for add cream and decorate cake. So add cream is giving adding white cream, and decorate cake is giving uh, decorating cake. Okay, and again it is also giving pineapple cake, 4 inches is ready, and 10 kgs. Okay, so this is what it is doing. Okay, now again for the again for this object, we are initializing the size and weight of chocolate cake class, and also using the super keyword we are initializing for your cake class, and we are printing it out. Okay, we are printing it out, add cream, decorate cake, all of these. Okay, so uh, this is how a model depicts open close principle. So that's all for this video. We are going to see the next principle in the next video.